So for this problem, the first thing we need to do is find the days. So looking it up, March 3rd is what day on the chart? 62. September 28th? 271. And June 2nd? 153. So the first thing we have to do always is find the maturity value of the original note. So to do that, we need to know the number of days. Well, it would start on day 62, and if it were allowed to run its course, it would end on day 271. So 271 minus 62 is 209 days. So we find our interest. The principal is $12,000. What's the rate? 0.08, 8%, and 209 over 360. Always ordinary unless you were told otherwise. It'll work out. 557.33. I took the 2 zeros off of here and then I just made that an 8 instead of a 0.08. Laziness takes over at a certain point. You do really weird things to save a couple of keystrokes. Yeah, I know. That's just me being lazy, punching in keyboard. No. So that means our maturity value is 12,000 plus the 557.33, which is 12,557.33. So what's our next step? Define the discount period. And of course, we had that 209 days. But what we're concerned about is the days that are left. So starting at June 2nd, going until September 28th. Now we actually have those days, so we'll just write it out. 271 minus 153, which is 119 days, correct? That's it? 109, no, 119. Yep. 118, never mind. Sorry. It is 118. So now we have to find from that step 3, that's the number of days left to go. Step 3 is to find bank discount. Which is going to be based off of the maturity value of the original note the discount rate is 11%, 118 over 360. $452.76 is the bank discount. So then the proceeds for Tom are based off of this maturity value minus that discount. So $12,104.57. How many of you had that one right? Okay, anybody have any questions on how we got to that? Any part of that that you're confused on? Now, as I said, in my mind, I think that is probably the most difficult process in the course, is going through that discounting a note. Okay then, tonight we're going to move on. The last couple of nights, last couple of weeks, what we've been talking about is simple interest. And as we had mentioned, in simple interest, interest only gets calculated in one of two cases. One is if there's an action on the note, on the account, so a payment being made in or money being drawn out, or the end of the term. But as we mentioned, banks don't normally do either investments or loans that are allowed to sit there with no interest for any extended period of time. Your home loans, your car loans, those are simple interest because you are expected to make a payment every month. So they know that there's going to be an action and therefore it'll trigger the interest to be calculated. But if you've made an investment and it's going to sit there for an extended period of time, they're not going to go 2 or 3 years without calculating interest. So what they're going to do is called compound interest. Technically, they are not. They are simple interest, but the interest is added in every month because you make a payment. So that's an action on the loan. Oh, yeah. So in that case, then they are compound interest. So they're adding in the interest every day whether you're making the payment or not. There are some also that do continuous compounding, which we're not going to get into because there's a table in the book for it, but it's just not worth our time. Every second of every day the interest is being built and added in, which is really kind of weird if you think about it. But yeah, the compounded daily, that's their way of squeezing a few extra pennies a year out of you.
Well, not really if you're a person who makes more than one payment.
Well, yeah.
You're paying less interest.
Technically, if we have time at the end of class, I'll show you the numbers on it, how it works. But it does, in fact, you can make, like if I make 2 payments today and then wait 2 months to make a payment, actually you come out ahead instead of making a payment now and another payment in 30 days because where the interest got hit.
If your car payment is $500 a month,
yep.
But you come across an extra couple grand and you make a payment.
Yeah. Well,
your interest after that is much lower.
You're exactly right. Your interest will be lower because your balance is lower. But it takes your ability to control the compound interest out of your hands. When you're using the simple interest like most banks do, you can control when the interest is added in by making 2 payments now, and then interest won't be calculated until you make your next payment. The daily compounded interest does still work out. If you did the math, even doing the payments on the same schedule, there is a few pennies more interest over a period of time.
If
you're only making your regular payments. Yeah. If you make your extra payments, though, it still works out even if you compared the 2 of them. A lot of banks now won't let you make, like some banks will let you pay ahead. You can get like 6 months ahead on your payments. Most banks now will not let you go more than 2 months ahead on your payments, partly for the same reason. Because they don't want you sitting there. If you're compounded daily, they don't care. They're going to figure out the interest and add it in anyway. But if it's not compounded daily, if you make 6 months worth of payments, then you don't make a payment for 6 months, it's going to sit there for 6 months without interest being added to it. So that definitely works against the bank. So anyway, compound interest, they figure out the interest on a regular period of time. So interest is calculated regularly. How often depends on, of course, the terms of that investment or note or whatever you're looking at. It can be annually, which is just once a year. Did I spell that right? I think so. Who knows? What's that? Who cares? This is math. It's once a year. Which is the simplest way, of course, of compounding. If you're going over lengths of times, a lot of times they'll start out with that. It can be semi-annually, which is how often? Twice a year, 2 times a year. Only really used for certain retirement accounts, not used very often at all. More common one is quarterly, which of course implies 4 times a year. Yep. Probably the most common one used is monthly, which of course is every month or 12 And then there are some that are not as common. There's daily and continuously. Larger chains use those two. Your smaller banks do not. What bank did you say you were working at? State Farm. And I knew that they actually do the daily, I believe, was it Wells Fargo does continuously compounding on some of their stuff. I can't remember exactly which one it is now. Is it Wells Fargo? Continuous is literally every moment of every day the interest is calculated and added into your account.
So what kind of makes now?
That really makes no.
10 minutes
Yeah.
more?
There'd be 10 minutes from now. I mean, it takes a certain amount of time to build up a penny's worth of interest.
Yeah.
But yeah. No, loan sharking, I mean, they're still charging competitive interest rates, but yeah, they're not charging you, 48% or anything like that. Yeah. Yeah. Like I say, it really is pennies difference, but it's definitely in the bank's favor. So that interest is figured out in that regular period of time, and then it's added into the account at the end of, for the next period then, that interest is already in there, and your new interest is based upon the total of that interest in. Hence the word compounding. You're receiving interest on top of your interest. So if we look at an example here, let's say we're going to invest $3,000 at, I'm going to use 8% to keep it simple for me. I know that's way high compared to today's rate. At 8% for 3 years. I'm going to use simple interest. The amount that's going to be worth at the end of the 3 years. And my amount of interest will be 3,000 times 0.08 times 3, which comes up to $720. So what it'll be worth, 3,000 plus 720 is $3,720. If I'm going to do compound interest, let's say I'm going to compound quarterly. We'd have to figure it out each quarter. We'd have to figure out the interest and add it in. So in quarter one, my interest will be 3,000 times 0.08 times 1/4 of a year, 1 quarter. That comes out to be what, $60? So if I add that onto my 3,000, I start out quarter two with $3,060. So my interest for quarter two is 3,060 times 0.08 times 1/4 again, which is $61.20. So once again, I add that on. I now have $3,121.20. So for quarter three, my interest is based off of that amount. Now I'm going to pause right there. 2 quarters, I've only made it through 6 months so far. I have to go 3 years. How many times would I have to do this? How many quarters in 3 years? 12. 4 times 3 is 12 quarters. I don't want to do this 12 times. So let's start looking for a shortcut. First thing is, what percent interest is really being added in every month? This $60 is really what percent? Well, the key to that is right here. 8% times 1/4 is really 2%. So it's being 2% interest per quarter. Now, if you recall, back, like 6-7 weeks ago or more now, when we're doing a percent increase like this, just like adding tax or other fees, We start out with the beginning balance. We're going to add our interest to that to get to our ending balance. We started out, the beginning balance was 100%. For adding 2% per quarter, the ending balance is 102% of what we started with. So rather than finding the 2% each quarter and adding it on, we could find 102% each quarter. So what that means is for quarter one, we could start out with the $3,000 and just multiply by 1.02. Where'd 1.02 come from? 102 is a decimal. I moved the decimal point over, make it 1.02. That would give me $3,060. Quarter two, I could start out with my 3,060 and once again multiply by 1.02. That would give me $3,161.20. How many times do I have to multiply by 1.02? 12 times. In math, do we have a mechanism for multiplying by the same number over and over again? We do. It's a power, an exponent. So 3,000 times 1.02 to the power of 12. 3,804.73. So $3,804.73 is what we end up with for compound interest. Now remember, simple interest we got $3,720. So you can see here by doing compound interest, we came out $84.73 ahead over 3 years. Now, right now, 8% would be a really high interest rate. The higher the interest rate is, the bigger the difference will be. So on your investments, it would not be nearly that significant. But it does make a difference over time. Now, a lot of things happen here in this calculation. So we're going to define that formula right there. Before we do that, I want to lay out some vocabulary. It is if you're doing, like, I don't want to say real investing. Professional investing. Actually, there are a couple of places I know of right now. Like there's a Heritage Funds where you can get close to 8% right now. It's like 7.8% they've been clearing over the last year. Actually, right now, I bet you could probably do a whole lot better than that if you got into the market doing bonds or mutual funds or individual stocks. But if you're going to the bank and putting it into a CD, no, you're not going to come anywhere close to it. But no. I have had very few years in the last 20 years where I have cleared less than 8%. I will say that. Actually, mine, I've been averaging between 12 and 13% over 20 years. So what we're going to look at here is we're going to start out with a beginning balance and go to an ending balance. The terminology we're going to use, the beginning balance is called the present value. Present value is, of course, right now, at the present. The ending balance, then, of course, will be called the future value, which will be at some date in the future. What we just did up here describes what happens in between here. Now, the way I'm going to describe this here is just slightly different than the way the book describes it. I'm going to find something called the compound interest factor. The example I did up above, I multiplied by 1.02, and I did that over and over again. In fact, I used the power to make sure I did that over and over again. Where did that 1.02 come from? It was 100% plus my annual rate divided by, I'm going to use N, for the number of periods in a year. Actually, I should be careful. I'm going to use it anyway. Slightly different than the terms that the book uses. So what I had here, 100% plus, my rate was 8%. Quarterly meant 4 periods in a year. That gave me 102, or 1.02. The power of 12 was my number of periods. That came by taking my number of periods in a year times t, which is my number of years. N times t was 4 periods a year, times 3 years, gave me 12 periods. So that's where I got that 1.02 to the power of 12. The compound interest factor is 1, that's 100% as a decimal, plus r, notice I use a little r, that's my rate as a decimal, divided by n, which is my number of periods in a year, to the power of n times t. Depending on which direction I am going here, my future value is equal to my present value. Present value, remember, is what it's worth right now. Bless you. Times this factor. 1 plus r divided by n to the power of n times t. So let's say I'm going to invest $5,000 at 9% compounded annually for 20 years. What is my present value? In this problem? $5,000. That's how much I have right now. What is R? It's 9%, but how am I going to write it? 0.09. What is N? How many times a year does this get? Once. N is 1. T is 20, my number of years. So to figure out the amount of, or the future value here, which is what I'm trying to find, I'm going to put in $5,000 times, in my parentheses, most of your calculators you don't have to put the times in front of the parentheses, 1 plus 0.09 divided by 1. Now again, you don't have to put in divided by 1 because it's divided by 1 doesn't change the number. I'm just putting it in there because it's good form. That's other times it's going to be more than once a year, so it'll be different than 1. To the power of 1 times 20. Now again, 1 times 20 is just 20. So if you're punching this in your calculator, you don't have to put that in. So I'm going to enter this in my calculator. 5,000 times, parentheses, 1 plus 0.09. I am going to put in the divided by 1 there just to fill the spot. To the power of, well, 1 times 20 is 20, so I'm just going to put in the 20 there. $28,022.05. Any questions on that? So now let's change this up. I'm going to invest that same $5,000, still at 9%, to compounded monthly for 20 years. Now, before we do anything, do you expect this to be larger or smaller than the 28,022.05. If I'm compounding more often, I will expect it to be larger. So the only thing that's changing here is n. So my future value is still going to be $5,000 times 1 plus 0.09 divided by, what's n now? Monthly, so it's 12. Close parentheses to the power of 12 times 20. Normally, before I punch this in the calculator, I figure out what this power is. What's 12 times 20? It's 240. So I'm going to punch this in the calculator. 5,000 times, parentheses, 1 plus 0.09 divided by 12, close parentheses, to the power of 240. $30,045.76. Not only is it more, it's over $2,000 more. Any questions? Yes.
You do that power of 240 again? I didn't get it this.
Where the 240 comes from?
No, I understand where it comes from, but I don't know, I couldn't get it on my calculator right.
Okay, so 5,000 times, open parentheses, 1 plus 0.09 divided by 12, close parentheses, and then I use the caret key is what I use for the power on my calculator. You might have an x to the y or y to the x key. And type in the 240. 30,045.76. Did you get to work this time?
No.
What model calculator do you have?
TI-30X.
Does it have, when you type it in, does the stuff scroll across the top and the answer appear down below? Is it 2 lines or is it just 1 line?
Yep.
Okay, so yours, you should be able to enter it just like that. So I'll do the keystrokes with you as you enter it. So 5,000, then times, open parentheses, 1 plus 0.09 divided by 12, close parentheses, caret 240. Then hit enter. On your calculator, it's on the left side about halfway down. Looks just like this one right there. Looks like this.
After that, we put in
The 240, yep. I'm sensing it didn't work still.
I think it's
No, I
that
don't know
little,
what it did.
that little
If
arrow
you do it all at
sign.
once, because I did it in 2 and it didn't work, but if you do it all at once.
And so yeah, the big key is don't ever hit the equals at all. You don't do equals until you get to the very end. Because if you hit the equals, it will screw it all up.
Okay, what exactly does that mean?
That's to the power of.
Okay.
Yep. Let's step you through it one more time. Make sure you hit your clear button about 3 or 4 times. Your AC button.
It came up syntax error.
Okay. So hit your clear button 3 or 4 times for me. Make sure your calculator is completely cleared out. Let's step you through it again. 5,000 times, open parentheses, .09. I'm sorry, never mind. Let's me back that up. Let's start all over again since I screwed up. 500,000 times, open parentheses, 1 plus 0.09 divided by 12, close parentheses. Now I'm going to pause there and make sure yours looks just like that so far. Don't hit equals though. Now hit the caret key, 240, and hit equals.
There we go.
Okay, good. Anybody else still not getting it to work? We got it going? Okay. Okay, so let's have you guys try one. You're going to invest $2,000 at 6% compounded quarterly for 8 years. See what you come up with. So to enter this, the present value is $2,000 times, parentheses, 1 plus, what's my rate? 0.06 divided by 4 because it is quarterly. You'd have to do times 1/4 instead of divided by 4. To the power of 4 times 8. Now again, I usually take the 4 times 8 and just get 32 so I can enter it a little easier on my calculator. So 2,000 times, parentheses, 1 plus 0.06 divided by 4, close parentheses, power of 32. 3220.65. It will always be 1 plus there, yes.
So for quarterly, you always do 4.
4, yeah.
So then the semi-annually would be
2.
You said you just, with power, you multiply that into 32. Is there another way you can do that, just as it stands, 4.8?
You could in your calculator, you'd have to put to the power of and then parentheses 4 times 8,
Oh, just.
then close parentheses. It's just simpler for me to multiply it out.
No, if I don't check, I find out the other one's simple.
Okay. So, anybody not get that to work out? Anybody want me to go back through that? Okay. There is another way of doing this in your textbook. There is a table on page, you can find it here. The old textbook, it was page 459. What are the chances it's on the same page?
not very good.
Not very good? That's kind of what I figured. Ooh, actually it is. Still page 459.
Wow. How'd you remember that?
What's that? I have it written on my lesson plan. My memory isn't that good. Heck, at this point, I've got a label on the dashboard of my car with my home address so I don't forget how to get home at night. So page 459 in your textbook. It is called the future value or compound amount of $1.
We can put like table. Is it 463? Is it this giant?
In the old book, it might be 463.
My book goes from 425 to.
Yeah, it'll skip pages. That would be the one on your copy. It's 463. Okay. So page 463.
Yeah,
Okay. That says future value or compound amount of $1? Okay. On that table, though, you'll see that down the left side, it says periods. And on top, it says rate per period. So this last example we did wouldn't even work in the table because how many periods are there? Well, 4 times 8 was 32 periods. If you look at this table, it doesn't go up to 32. Yeah, it is very convenient. So let's look at an example here that will work on the table so we can see how the table works. So let's say we're going to invest $40,000 just for fun at 8% compounded quarterly for 5 years. First thing I'm going to find is my rate per period. That rate per period is my percent, my annual percent, divided by the number of periods in a year. How many periods are going to be in a year here? Quarterly tells us 4. So 8% divided by 4 is 2%. So on top here, I'm looking at 2%. How many periods? 5 years. Quarterly is going to be 4 times 5, or 20 periods. So on the left side over here, I'm going to look for 20 periods. I'm going to follow the 20 over, the 2% down to see where they intersect. And I find that they intersect at 1.48595. Does everybody find that number? Yes? Okay. That is what's called a compound interest factor. Does that name sound familiar? No. That's found by just doing this. So we got that 1.48595. I could have found that by just doing 1 plus 0.08 divided by 4 to the power of 20. .4859. Notice theirs is rounded off. This goes on. Most of the time, using this factor out of the table and using our formula will be within pennies of each other. But the larger the numbers get, the longer the period of time, the more likely they are to be off. So anyway, how would I find then the future value here? Well, I'm going to take my present value, $40,000, and instead of multiplying by this number, I'm going to multiply by this factor out of the table. 1.48595. So $59,438. Realistically, that's slightly off. So I use the formula. 40,000 times parentheses 1 plus 0.08 divided by 4 to the power of 20. It's technically 59,437.90. So it's off by 10 cents. The formula is definitely more accurate. Problem is my math lab tends to use the table.
So, should we use the table? Are they going to give us ones that fit the table?
They will give you ones that fit the table. If you would prefer using the formula, I will go back and regrade these quizzes. I know a couple of you actually emailed me on the quizzes from last week. For these last several weeks, I go back and regrade all the quizzes manually to make sure. So if you want to use the formula, just when you get done with the quiz, it'll tell you, oh, you got 3 out of 10 correct. Go back in and look at them. If you're off by pennies, you know it's just because you use the formula instead of the table. And I will catch that and I will change that. It is, but I mean, they have to pick a method and go with it. Even in most of our accounting classes here, they use the table value. In some of your basic investment, they will actually use the formula, but so anyway, let's have you guys try one more on your own. I'll have you guys try one on your own using the table. So using the table, we're going to invest $800 at 6% compounded monthly for 2 years. Find the future value. So what is our rate per period on this one? Our rate per period. How do we find the rate per period? Perfect. We take our annual percent, which is 6%, divided by the periods in a year. Since it's monthly, that is 12. That is 0.5%. So in our table, we are looking at 0.5% column. How do we find the number of periods? Our periods per year, which is 12 because it's monthly, times the number of years, which is 2, gives us 24 periods. So on our table, we're going to look at 24. So we follow 24 and 0.5 gives us 1.12716 is our compound interest factor. So our future value is $800 times 1.12716. $901.73. Anybody get something different? Perfect. Okay, it is time for our break, so let's go ahead and take a 10-minute break. We'll come back at 7:31.